Bayesian 2.0. Our pure, natural, refreshing mineral water comes from the ancient river Statz. Best of all, a bottle of Bayesian 2.0 has 200 milligrams of bayesium, a mineral that 4 to 5 doctors believe reduces the risk of conditionitis.
Jimmy goes to the grocery store Baysmart to buy some water. He wonders what the company means when they say a bottle of Bayesian 2.0 has 200 milligrams of bayesium. Is that on average? Could it vary a lot by bottle? And how many doctors were surveyed? And how can they distinguish correlation from causation?
Sources. Baysville, Continuopolis, and or Discrete Town. Are there major differences between these sources?
3 segments of the Statz River are used as sources for Bayesian 2.0. One in Baysville, one in Continuopolis, and one in Discrete Town. The average bayesium level is different for these 3 sources. On average, a bottle sourced from Baysville has 250 milligrams of bayesium. A bottle from Continuopolis has 190 milligrams. And a bottle from Discrete Town has 160 milligrams. Even within each of these sources, there is variation. For a random bottle, how much bayesium do you expect it to contain? Is it the simple average, 200 milligrams? A, it is the simple average. B, it's more than the simple average. C, it's less than the simple average. Or D, it depends. As in so many other situations, the answer is that it depends. The average bayesium level is a weighted average of the separate average bayesium levels for the 3 cities, where the weights depend on what proportion of water is sourced from each of the cities. The simple average makes sense if 1/3 of the water comes from each of the cities. But if, for example, 2/3 of the water comes from Discrete Town and only 1/6 comes from Baysville and 1/6 from Continuopolis, then the overall average is 180 milligrams. In general, let Y be the bayesium content of a random water bottle, and B, C, and D be the events that the water in the bottle comes from Baysville, Continuopolis, and Discrete Town, respectively. Then the overall average is a weighted average of the separate averages. The expected value of Y is E of Y given B, P of B, plus E of Y given C, P of C, plus E of Y given D, P of D. Let X be a random variable that indicates which city the water comes from, say with X equals 1 meaning Baysville, X equals 2 meaning Continuopolis, and X equals 3 meaning Discrete Town. The above identity can be expressed even more compactly as E of Y equals E of Y given X. This identity is known as iterated expectation, or Adam's law. Jimmy is also concerned about how much the bayesium content varies by bottle, not just the average amount in a bottle. Suppose that a bottle is equally likely to be sourced from each of the 3 cities. For each source, water bottles have a standard deviation of 10 milligrams in their bayesium content. What is the overall standard deviation of bayesium content in a random water bottle? A, 10 milligrams, B, more than 10 milligrams, C, less than 10 milligrams, or D, it depends.
Is the overall variance the weighted average of the 3 separate variances?
We can answer Jimmy's question visually. If the answer is yes, then moving a city's pile will not change the overall standard deviation. But in general, the overall standard deviation does change when we move a pile, even though we are not changing the separate standard deviations. The key is that there are 2 types of variation. The bayesium content varies within each city, and it also varies between cities. Remarkably, we can get the overall variance simply by adding these 2 contributions. The variance of Y is E of the variance of Y given X, plus the variance of E of Y given X. The first term is the average of the separate variances for each city. The second term is the variance between the separate averages for each city. This identity is known as Eve's law. In this example, the variance of Y given X is 100, since within each city the variance is 100. and e of y given x is 250 if x equals 1, 190 if x equals 2, and 160 if x equals 3, which gives that the variance of e of y given x is 1400. By Eve's law, the variance of y is 100 plus 1400, which is 1500. The standard deviation is the square root of this variance, which is about 40 milligrams. This is much higher than 10 milligrams. Just using the average of the three separate variances ignores the second term in Eve's law. Jimmy is right to be skeptical and to seek more refined data. With multiple sources of water, there are multiple sources of variation.